Alright, so let's start looking at the law of cosines. So the law of cosines actually has three separate versions. So we're still starting with our general triangle, so this will work for any triangle. We've got angle A, opposite side A, angle C, opposite side little c, angle big B, opposite side little b. And so the law of cosines has three different versions. The first version we can see is c squared is equal to a squared plus b squared minus 2ab times the cosine of angle C. We have b squared is equal to a squared plus b squared minus 2ac times the cosine of angle B. And a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. So it looks like a little bit like the Pythagorean theorem, but we have these kind of error terms over here that end up being 0 when one of those angles, or when C would happen to be 90 degrees. Cosine of 90 degrees is 0, so that term would disappear, and we're back to our usual old Pythagorean theorem. So we can think of the law of cosines as generalizing our Pythagorean theorem. But the way that we can remember it is really like this. So if we pick two sides, so we can say that the length of one side squared plus the length of another side squared minus 2 times the product of the lengths times the cosine of the angle in between those two sides is equal to the length of the opposite side squared. So that when we have our triangle here, that we have so one side squared, so a squared plus b squared minus 2 times the product of ab times the cosine of the angle in between a and b is equal to the square of the length of the side that's opposite that angle, so c is equal to c squared. So practicing that mnemonic may help you to remember kind of the relationships and where everything needs to go in our law of cosines. So our law of cosines will really cover two different cases. So one case is when we know two sides and we happen to know the angle in between. So in this case, this is our side angle side condition. Okay. So suppose that we're given a triangle and we know side C is 16, angle A is going to be 60 degrees, and side B is 21. So since we know angle A, so that's the angle that we know, and the angle is in between sides B and C, we'll use the version of the law of cosines that has the angle that we know. So since we know A, we have a squared is equal to b squared plus c squared minus 2bc times the cosine of the angle in between. So plugging in the values that we know, we've got 16, or a squared is going to be equal to 21 squared plus 16 squared minus 2 times 21 times 16 times the cosine of 60 degrees. So what that ends up giving us is a squared is equal to 361. Taking the square root of both sides, we end up with a simply being 19. Okay? So now we can use the law of cosines to find b. Since b is the angle across from the longest side, it will also be the largest angle. And so if we have an obtuse angle in this triangle, then b is going to have to be it. So if we plug in, so we go to our law of cosines involving angle b. So we've got b squared is equal to a squared plus c squared minus 2ac times the cosine of b. Plugging in values that we know, so b is 21, a is 16, or a is 19, c is 16 minus 2 times 16 times 19 times the cosine of b is going to give us 441 is equal to 256 plus 361 minus 608 times the cosine of b. So simplifying that a little bit, we end up seeing that the cosine of b is going to be 441 minus 617 over negative 608. So putting that in the calculator, we get that the cosine of b is going to be about 0.289473684. If we use our arc cosine function to find out exactly what b is, we see that b is going to be 73.17355 degrees. Now the nice part about the arc cosine function is that the range is going to be between 0 and 180 degrees. And so if we happen to have an obtuse angle inside this triangle, which it would be b, arc cosine is going to tell us that fact. And so that's why arc cosine is a really nice thing to have. So with arc cosine, we will ever only have just one solution when we're doing this. So the law of cosines, no matter what the condition, will only ever have just one triangle satisfying that. So that's what we've got so far. A plus b plus c is 180 degrees. We know A is 60 degrees. B we just found was 73.17355 degrees. And so that ends up telling us that C is 46.83645 degrees. And so we can use the law of cosines to find our remaining angles. Alright, for the second case that we deal with the law of cosines is the condition in which we happen to know all three sides of the triangle, but we don't know any of the angles. So this is our side, side, side condition. So an example of that one, we've got side C is 18.2, side A is 24, and side B is 12.8. So as we're looking at this, side A is going to be the longest side, so its length 24, which means that angle A has to be our largest angle. And so if this triangle is going to contain an obtuse angle in it, then it's got to be angle A. And so we can use the law of cosine since that's the largest angle. Let's find him first. So, and that's a general rule of thumb. If you know all three sides, find the side that's the longest side, and then from there, find the largest angle that's in there. So we go to the law of cosines. That involves angle A. So we've got a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. So plugging in the values that we know the sides, is going to tell us that 24 squared is going to be equal to 12.8 squared plus 18.2 squared minus 2 times 12.8 times 18.2 times the cosine of A. So if we move all of that over to one side and get cosine of A all by itself, then we get an expression that looks something like this. So our cosine of A is going to be 24 squared minus 12.8 squared minus 18.2 squared divided by negative 2 times 12.8 times 18.2. Plugging all that nasty mess into the calculator, we get that the cosine of A should be approximately negative 0.18525641. So if we use the inverse cosine on that value, we see that the arc cosine of that is going to be 100.68 degrees. So sure enough, we do have an obtuse angle in this triangle. We can only ever have one obtuse angle in a triangle if we ever have one. And so we found it. So we found the biggest angle. It's 100.68 degrees. So since we know the largest angle, we can make our lives a little bit easier now and turn to the law of sines to find the other angle. So if we go to the law of sines, we'll see that the sine of 100.68 degrees So that was angle A over the length of side A, 24, is going to be the sine of angle B divided by the length of side little b, which was 12.8. If we solve for the sine of B, we get sine of B is going to be 12.8 times the sine of 100.68 degrees divided by 24, which is approximately 0.524094691. Since B has to be an acute angle, we can just take the arc sine to guarantee that we've got an angle in the first quadrant. We don't have to worry about any second quadrant angles because we've already found the obtuse angle. And so B, being the arc sine of 0.524094691, is approximately 31.61 degrees. So now we can come back to using our tried and true formula. So we've got A plus B plus C is going to be 180 degrees. So 100.68 plus 31.61 plus C is 180, making C 47.71 degrees. And so what happens? We get, whoops, I don't know if I can get those on there. So we've got A is 100.68 degrees, B is going to be 31.61 degrees, C, if I can get it up there, let's see. So C is going to be 47.71 degrees, and the sides that we were given, A was 24, B was 12.8, C was 18.2. So this works through the two cases that we have for the law of cosines. This should let you do all of your homework. So good luck.